Hello, everyone, and welcome to a new episode of the Kiln Restaking Rendez-Vous. Today we have Douwe from HyveDA. How are you doing today, man?
Doing good. Glad to be here.
Cool. We're going to be talking about a lot of cool things: data availability, roll-ups, AI, DePin. But first, can you give us a little personal background and tell us kind of like your backstory as to how you started to work in the crypto space?
Yeah, sounds good. My back story goes back all the way to when I was about 12 years old. That's when I started to look into how to code a website. That was first everything related to cars, but eventually the whole hobby regarding cars went away, but the nerding out for coding stayed with me. So then it was about 2016, 2017 that I started digging into Ethereum, and I became a big fan of smart contracts and all of the stuff that you could code on Ethereum right away. So that's when I started, playing around with what CryptoKitties was at the time, trying to build a fork of that. But it also quickly kind of turned into this very big obsession with data. So I started to build data indexers, trying to do analytics, trying to automate trading, so that data obsession was there quite quickly. And then turn back to about last year, or fast forward to about last year. That's when I had this idea to build essentially a whole different idea. I had this idea, but it came to indexers to decentralize that more and integrate machine learning into that. That wasn't really possible because there was no high throughput layer to actually publish all this data on. So I started to play around with how can we make this super high throughput data publishing layer, aka a high throughput data availability layer. That's when I started to draft up design, created MVP, tried to talk it over with the Symbiotic team, and turn it into a reality. So that's how we started Hive about last year, and that's how we've built a data availability system that can handle 1 gigabyte per second in throughput.
Super cool. Let's just like rewind a little bit and remind the audience what data availability or like a data availability layer is.
Yeah. Data availability. It's very coupled with rollups. It's something that got first pointed out by Ethereum Foundation as a problem. Then Lazy Ledger or Celestia proposed the first kind of solution to it. But it's essentially this layer where rollups specifically can publish their data. And it has very good security assumptions and security guarantees. So you essentially make sure that every node in the system has seen the data, so that you have a high enough guarantee that your data is available. And then with all the participants in the network, you can always fetch back your data. So rollups use this, for example, to publish their blocks on. And then they essentially adopt the liveliness guarantee from the DA layer. So that can be Celestia, that can be HyveDA, or that can be Ethereum. However, what we identified is that DA is not only useful for rollups, but it's also super useful for all kinds of other applications. You can build like a central limit order books. So essentially a DEX with an order book on a DA. You can publish your AI traces on a DA. You can publish your machine learning context or input on a DA. You can publish all kinds of very useful information on a DA. And essentially these use cases that fall out of the spectrum of rollups, they are much more demanding. So they need much more throughput than your typical DA that only does 1 megabyte per second or even less. So essentially, that's essentially what DA is, but also how we extended it towards these different use cases that are not rollups.
Super nice. Yeah, you already introduced the topic a little bit, but DA has been around for a while in the crypto space. And like, yeah, 12 months is a while in the crypto space, but I'm really curious to understand like how HyveDA like integrates and fits into the broader like DA ecosystem. You've mentioned a couple like DA projects. What is the what is the trade-off that you have chosen in the design of HyveDA to make it has like have a competitive advantage or like make it different from other DA solution?
Yeah. Um, there are some trade-offs to it, of course, as well. One thing that makes us very different is that we didn't choose to build like an L1 to do our DA. What we wanted to build was really like this first principled view of what should a DA layer be. and then actually build only the data availability layer, but make it in such a way that it can be separated from an L1, not in terms of like a service, so that it's like semi-centralized, like a data availability committee, but really this decentralized data availability layer that can be essentially attached to an L1. And I don't think this has ever been done before, so it was quite a technical challenge to actually figure out, but we got there in the end. But this is also like our biggest differentiator. Like one thing is throughput. So everything in our system is very fast, everything is parallelized, and that's great. But another thing that we really wanted to do is make this kind of ecosystem agnostic. So whether you want to be building on Ethereum or on Avalanche or on your own Cosmos SDK chain, essentially we wanted it to be able to spread DA to all of these ecosystems. So that's what we did. So our DA layer doesn't have a concept of finality. It doesn't have really rough consensus. It is Byzantine fault tolerance, so it does have coordination between the nodes, and it does have some form of what you could call consensus. But there's no transaction ordering and no finality. This is something that really falls outside of our DA. So for example, with Symbiotic, we use restaking and then a smart contract on Ethereum, and then we essentially adopt the finality from Ethereum, and we use slashing and restaking for the security guarantees when it comes to the finality of the DA batches. We can also integrate this natively into a sequencer. We can integrate for dedicated blob space. We can integrate this into Tendermint consensus. So it's essentially like this completely ecosystem agnostic way of doing DA. The drawback of this, of course, is that we don't have finality natively on our layer. So that means when we are building on Ethereum, we will adopt the finality of Ethereum, which is quite slow. It's like 12.8 minutes, I believe, so 2 epochs. If we build our own consensus, we could make this faster, but then that's another problem, because anyone who wants to build on Ethereum wouldn't build on this external layer. So it's a well-calculated drawback, essentially, of what we're building.
So is this essentially why like some other solution have like a consensus layer? Is that they could also be like a fast finality engine for whichever service or rollup is using them?
Yeah, I think that's a technical justification of building your own layer, or your own L1, sorry, because you can have your own choices for finality, your own consensus choices. So you can essentially scale your own DA blockchain faster than Ethereum, for example.
But you also have like networks that exist, or like specific services that only focus on the functionality part. So I mean, maybe you could say that like with HyveDA and one of these services or networks, you could actually like complement these I guess these data availability layers that have a consensus.
Yeah, you could. What you could do is like if you want to build a rollup on Ethereum and you want to use HyveDA underneath, then you adopt the finality of Ethereum. There's no real way around it. You can't like change the finality gadget yourself in Ethereum. But if you have your own Cosmos SDK chain and you want to introduce DA on the L1 itself on the Cosmos SDK, then you're using Tendermint. You have very fast finality when it comes to Tendermint. So in that case, you could have fast finality for your DA as well. But this is completely up to the choice, essentially, of the implementer, if they want to build on top of Ethereum or if they want to build on top of a chain that has faster finality.
Got it. Now, if we can better understand like how HyveDA works in practice, could you walk us through like the life cycle of a blob, like from submission to attestation and finalization?
Yeah, yeah. So in our system, we don't have like a concept of like a leader or like a block proposer. So that's something I want to start off with, because that's going to be important for the rest of the life cycle of the blob. So essentially, you have your blob. That's what you start with. You have some data that you want to submit to the DA. Let's say a 20 megabyte file. The first thing that you do is you divide these up into shards. So that's the erasure encoding, which essentially means that if, let's say, 60% or 50% of the data is missing, you can still reconstruct the blob from the remaining 50%. That's what erasure coding does. It's this error correcting code. So that's the first step. You divide these into these chunks. Then every chunk will get its own proof that it is part of that original blob. That's what we call the validity proof. In our system, we use KZG for that. So the same KZG that you can find in Ethereum, for example. Once this is defined, so once these chunks and these proofs are defined, you submit each chunk to a specific validator. So in our case, we don't send the whole blob to like a mempool and then the leader selects it and divides it into chunks and sends it to random validators. For us, it is the case that every chunk is assigned to one specific validator, and or operator in our case would be a more logical term. But the operator then verifies that this chunk is indeed part of its own receiving data set. So if that operator is needing to receive all the indexes of 20, it will make sure that it only receives a chunk with index 20. Once it has verified that and the proof and all the data in there, then it will store it. And what will happen then is that operator will create a batch with all the transactions that are valid. So that those are all essentially the blob IDs that it has received and verified. And it will propose that batch to the other operators. This happens completely concurrently because every operator will receive a chunk in parallel. They can all create their own batches. Some operators will receive different chunks than other operators, so they can all propose chunks or blobs or batches of blobs in parallel. So all of these operators are proposing batches to each other. All of the other operators will also check if they have all of these blobs from within these batches in their own nodes. And it's key to remember that they don't verify that they have the entire blob in their node, but only that chunk belonging to that blob that belongs to their specific operator. So they verify all of this, and if that is all valid, then they sign off to that batch and submit the signature. And then eventually you get a Byzantine fault tolerance, so 2/3 plus 1 of threshold signatures, and then that batch is deemed to be essentially final, but not finalized as in ordered and everything. It is just deemed to be accepted by the network. Once a batch has been accepted, then that batch can be used as the parent batch of another batch that will be proposed in the future. And what you get here is like this DAG kind of structure where all of the batches are connected to each other and they can all be processed and proposed in parallel. Once these batches have been accepted, they can be integrated or they can be accepted by the consensus as well. So if the consensus deems that this batch has enough signatures, it has the right validators attesting to it, it has like the right amount of stake behind it, then it will be included within a block as well inside of the consensus. So usually that also involves like checking that there is actual fee payments for each blobs and checking all of these rules that are specific to the consensus to actually include blobs. Once it has been included inside of the consensus, then there's all kinds of different ways to maintain the data availability. What we do with Symbiotic is that we also have proof of storage for each node. So there's essentially this cryptographic proof that all of the data that should be in the node is in the node as well. And that will be uploaded as well to the smart contract together with the header of the batches. And then using slashing, we can make sure that in case that data is not available or the proof of storage essentially is not correct, then you can slash the operator that has been malfunctioning. So this is essentially the lifecycle of a blob. It's pretty complicated because there's so much happening from proposing and batching and this whole DAG structure. But this is essentially the lifecycle of a blob.
Super interesting. Going back a bit with like the capabilities of HyveDA as a data validity layer as a whole, like you mentioned that like the throughput could be 1 gigabyte per second. Can you talk a bit about like the real world examples of potential use cases that can be enabled by this type of data availability throughput?
Yeah. One thing that I had a presentation about this as well in the Code Club. It's a good question, and it's sometimes hard to wrap your head around because not everything in like L2s, for example, is high throughput. But one thing that I always like to mention is central limit order books or clubs. Essentially, every exchange in the world that you know is a club. Binance is a club, Coinbase is a club, even the New York City Stock Exchange is a club. And all of them have pretty good user experience because of this kind of architecture. And right now, if you want to build a club, you're building your own chain for this. So Hyperliquid, for example, is a club as well. What I would love to see built and what what HyveDA is essentially the only DA that can provide this, is building your club natively on Ethereum, where you store the order book in the DA, and that DA is maintained, or that the order book is maintained by this decentralized set of validators. And then you have the entire state, token issuance, liquidity sitting on Ethereum. Every time there's an order in the order book that matches, you can just match it on Ethereum in a settlement contract. The same way that OpenSea does this with their settlement contract for Seaport, you can build your own settlement contract that's maybe even more gas efficient and only built for ERC20s, and then you can settle your trades completely on-chain. What this would do is essentially build this native order book on Ethereum that can handle like millions of trades per second posted on the DA. It can handle quite a few trades as well being matched on Ethereum itself. But you can also build this on an L2 if you want to go really high throughput. But the essential thing here is that you as a user don't have to wait for a transaction to be posted on your blockchain. You can just post your transaction off-chain. This will be handled within milliseconds. You can do millions of orders at a minute. But you can only do that if you have a high throughput DA. If you build this on your own chain, you can do high-ish throughput, but usually that leads to centralization. Plus, if you build your own chain for this, you're probably not going to have any DeFi protocols on that, especially if it's semi-centralized. And this is essentially like the biggest pro of having a DEX, is that you get access to all of these DeFi protocols as well.
Got it. And you also mentioned AI and DePin applications. Can you talk a bit about like what are like the issues that they're facing today in terms of data availability and like how HyveDA can solve this?
Yeah, there's a lot of it goes very broad when it comes to like AI and DePin use cases. When you talk about AI, like one thing that you can do, for example, is all of this context that you take as a AI agent, or all of this information that you use to fetch stuff for a machine learning environment. If you do this in a decentralized context, in a trustless context, you need to be able to verify that your AI agent or your machine learning model has used this specific data as context as well. If you keep that data off-chain and you only post like the roots or something like that to a blockchain, then there's no way for you to trustlessly verify that the data that you say is being used as context is actually being used as context. So for a trustless AI agent, essentially, you can withhold the data and then nobody will ever be able to verify it. So it really comes down, like there's different methods of doing it, but it all really boils down to making AI verifiable and making machine learning networks verifiable. So that's one of the things for AI. For DePin, it's the same thing. If you run a network of machines and they need to be able to essentially trustlessly cooperate or collaborate, you need a way to actually publish the data that they have been using, whether that is IoT data or certificates for zero knowledge proofs like CKTLS. All of this kind of data needs to be published somewhere. And with a DePin network, you usually are working with sometimes thousands or even hundreds of thousands of machines. You need to be able to do this in very high quantities, very high volumes. And the only really way to do this is a high throughput DA layer to do this trustlessly.
Nice. Going back a bit to HyveDA and Symbiotic, this symbiosis, HyveDA was kind of built with I guess like with the idea in mind that it would become a symbiotic network. Like there was no, I guess like work at the beginning, and then you say like, oh, maybe we're going to use this. It's going to work. Like, did you already know like from the get go that like you would be like symbiotic network, like even ahead of like working on HyveDA?
The exact like order of events is that we first came up with the DA itself, but we always wanted to use restaking for it. But we didn't really have EigenLayer obviously already existed, but we didn't really want to go with a network that didn't have slashing yet, as well as that we saw some stuff about the modular approach of Symbiotic, and that quite spoke to us. And after talking with the team and actually seeing how it worked under the hood, it became quite clear that Symbiotic was the best contender when it comes to restaking and shared security. So we didn't necessarily want to build it on Symbiotic from the get-go, but as soon as we heard from Symbiotic and as soon as we saw how it exactly worked, we did want to build it nowhere else but Symbiotic.
That's great. Like I would love if you could develop a little bit on that, on like what like restaking and shared security like can like um c- 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 can enable really, like when you're building like an application like yours. Like, is it like something that's specifically valuable if you're building like a DA layer, or is it something that can also be extremely valuable if you're building like other types of protocols? And later I would love if you could explain a bit like how exactly like HyveDA and Symbiotic work, how it works with the vaults and the operators, but we'll go into that a bit later.
Yeah, yeah. Though I think first of all, like I think it's not just DA that can profit from a shared security and restaking layer like Symbiotic. I think any whether it's centralized and verifiable or completely decentralized, if you want to maintain some kind of game theory where you maintain integrity of all the players, then slashing will become part of that. But then having to essentially start up your own assets where all kinds of liquidity has to flow into your asset instead of staying in the asset that they're already in. That's going to be a very big pain to actually set up. While with restaking, you essentially have this liquidity that's already available and you just are reusing it. And that's a great way to get high TVL, which for a lot of security guarantees or security assumptions, you need a high TVL enabled to scale past a certain level. So that's the great thing about restaking, is that you can acquire a lot of TVL much more easy than if you were to create your own asset for it. Another thing with shared security that really becomes much as a very big advantage to us is that we wanted to create this DA layer that's not just secured by Ethereum, but also secured by Bitcoin, but then in its own kind of environment or subnetwork, essentially. Because if you are a Bitcoin rollup, for example, or building something on Bitcoin, you don't want to be using Ethereum as your underlying security asset. So that's why why shared security is so great, because you now don't only can restake Ethereum, but you can also restake Bitcoin, and you can share the Bitcoin that you are using on one subnetwork on the other subnetwork, or even between two networks in its entirety. And this is not just for Bitcoin, this is for essentially all tokens that have a collateral on Symbiotic.
Nice. So I guess like the multi-collateral approach of Symbiotic was really something that was valuable to you. Like you mentioned also like the modular part of Symbiotic is great, and the fact that of course it has slashing is extremely valuable if you had actual security.
Yes, it's exactly.
Can you tell us a bit like what are the different types of collateral that like your network accepts today?
Yeah, so right now we only do Lido stake ETH. So that's something that we're starting out with. And essentially, we can do any collateral. So if there's a use case that wants to be building on whether it is Bitcoin, whether it is USDC, whether it is Trump coin or some meme coin, which I really doubt there's going to be any use cases for that. But essentially, any collateral can build, or any collateral that somebody wants to build on can be integrated in the VA. And we have this DA layer as well that splits up essentially between these different collateral assets. So you might only want to post to operators that have Ethereum or enough Ethereum as the security asset. You might want to post only on Bitcoin, or you might accept both. So both in the smart contract or the liquidity side of things, and in the actual technical DA layer, there's this clear separation between them. And that essentially makes it possible to support an infinite amount of tokens and even combination of tokens.
Got it. Get it. Um, so in the long run, you would have like a permissionless approach to like what types of collateral could be accepted as security?
Yeah, it will be a permissionless approach. There might be some like governance voting on it, perhaps just to kind of maintain that it doesn't become a meme coin plaza. But it's essentially going to be completely permissionless. That's the idea, at least.
Got it. Got it. Makes sense. Um, and I see also today that you have about like $44 million of economic security. Do you is it? I'm guessing that it's capped today. Do you have plans to like accept more economic security? How do you kind of see like your need in terms of economic security?
Yeah, yeah, it's kept right now, as we are not mainnet yet. So this is really pre-deposit, so that we have some TVL ready, and already have some momentum to accrue TVL when we go to full mainnet. But as we move closer to mainnet, we'll be keeping it or we keep increasing the cap, and eventually it will be uncapped, of course. So there will be an unlimited amount of collateral that you can deposit in there. The real amount of collateral that's in there or that needs to be in there is a bit a complex topic. Essentially, it's a very nuanced topic. An easy thing that we can say is we need to have as more TVL than people who integrate RDA, because then you can have a data withholding attack that's actually lucrative for people to do. But there's all kinds of ways to offset it as well. So it's a bit more nuanced topic. But yeah, essentially we can have an unlimited amount of TVL, but there's definitely a certain minimum threshold to at least withstand data withholding attack attempts.
Yeah. Actually, like, it's great. Like, could you dive a bit deeper into like exactly like how you mitigate like data withholding attacks? Like what role like the data availability committee like plays in this process? Also, I believe that like I've seen that like for example in the context of EigenDA, like this is where like they would use like the eigen token that's like could be slashed subjectively. Is it something that would make sense for you guys, like or is it something that like isn't really like needed to punish this specific fault?
Yeah, there's it's definitely needed to punish the fault. So in our case, what we do instead is we don't really have this intersubjective slashing or anything like that. What we essentially do is that when your data is not available, so we have this game essentially where you can check whether data is available, yes or no, in a cryptographic way. If your data is not available and the nodes that have been honest, so they're not posting the data that is needed to make sure that the data is available, they will be punished. If the data is available but they're not participating in it, then they'll just be punished. But if the data is really not available, so you really can't reconstruct it, like so many shards are gone that you can't reconstruct the data, that's when these nodes that have been dishonest will be slashed. And this is not something that's like intersubjective slashing. They'll just be slashed fully. And that's why it's also important to maintain a high enough TVL. Because if we have 1 billion in TVL, but one of our integrators has 20 billion TVL, and a node or one party can actually win most of that 20 billion TVL or just enough of that 20 billion TVL by withholding the data, then it doesn't matter to this party that $1 billion will be slashed. So this is why it's important to actually maintain a high enough TVL.
Got it. Moving on a bit more to like the role of the operators and restakers there, like of course you've explained how it's important to have TVL. The operators are managing the delegator as a stake, and they are doing work. The Kiln will be doing work when you guys go to mainnet. It'll be interesting to understand like how like value accrues to the operators and restakers, and if you have like if you're planning to like incentivize this, or if you're planning to do like revenue sharing with operators and restakers.
Yeah. And it's we're excited to be working with you guys as well. There'll definitely be rewards for Kill. Not for the rest now. There will be rewards for everyone. So yeah, there's like a couple of incentives there. There's obviously like the fee that will be paid by the blob submitter. So if someone wants to submit a blob, then there's just a fee attached to that, and that will be part of the reward. There's also, of course, going to be all kinds of other rewards to it that I'm not going to say too much about yet. But there's certain stuff that you can do when it comes to inflation. But essentially, it is a completely decentralized and permissionless way of distributing rewards based on essentially how much work one operator has done, plus some more sustainable tokenomics when it comes to the fee reward. And the good thing about this as well is that we will be using Ethereum as like the native token or I guess you could call it gas token or fee token. So all of the operators will be rewarded in Ethereum. But if you're participating on a Cosmos chain or its own Cosmos SDK, then that might be the native token of that chain. So it's essentially completely possible for operators to opt in into certain tokens, but not opt in into other tokens if they don't believe in that asset, for example.
Yeah, makes a lot of sense. And we're also very excited to support you guys, of course. One thing I wanted to ask you about before we go into the closing questions is I guess like what's next on the HyveDA roadmap? Like what are the milestones that you're looking forward to? Like what does mainnet look like? Like do you have like a pipeline of applications that you're looking forward to support? Can you tease a bit the mainnet launch to us?
Yeah, it's mainnet will be very interesting. The things that I'm most excited about is we talk with a lot of very interesting DePin applications that are essentially like real world applications that just need a replacement for AWS S3 essentially. And this is something that's super exciting to me as we want to grow our throughput even far beyond 1 GB per second. And then we really talk about this transient blob storage layer. So those are very exciting use cases. Another one that has been grabbing my mind has been the recent development of OP Enclave or Enclave. I don't know exactly how to pronounce it. Please correct me if I'm wrong. But this is something that Base Chain obviously just released. And this is this dedicated blob layer for L3s. And it's very interesting. They got some shit for doing this with AWS S3. But I kind of understand from their perspective, especially because this is the first iteration. But what we built with this ecosystem agnostic DA is essentially makes it possible to have dedicated blob space within OP Enclave, but completely native to the base sequencer. So you really become this L3 that adopts all the security guarantees and liveliness guarantees of the base chain sequencer. And this is possible for base, this is possible for any other L2 as well. So that's something that really grabbed my mind, and I've been thinking about that a lot lately as a real possibility to essentially integrate DA natively into different L2s.
Super cool. And do you already have like a timeline for like when mainnet will launch?
No public timeline yet. No.
We'll stay tuned to know more about it, but it's fine. Just wanted to ask you like final question, like outside of data availability, like what is the topic that keep you most interested in Web3?
Um, I think, to be honest, right now, the DeFi protocols seem the most interesting to me. Even though I usually don't care about DeFi at all, I'm more like really in it for the tech. So really, like I really love the graph, for example. That's like some really great technology that they wrote. But lately, I've been grappling more into DeFi. There's a lot of stuff that's happening in restaking, obviously. Lido V3 just came out, but also because it really kind of is maturing. So Avi still exists, yay, and they're still doing like as one of the best what is it, lending protocols in DeFi. And it's becoming more and more interesting to me how many parties there are, the curators that are participating in it, the role of vaults in here. And it's becoming more of this mature ecosystem with really mature players in it. And the technology, the smart contracts also are actually very interesting to look into. So this has been more on my mind lately.
Amazing. Well, Douwe, thank you so much for coming on the podcast. It was definitely like great to chat with you. Very excited about what you're launching and looking forward to support you guys. Before we end this, could you direct our listeners to any resource that they should look into if they want to know more about HyveDA? And could you also share maybe like your socials?
Yeah, for sure. Yeah, thanks for that opportunity to give to me to share a little bit more about Hive. But yeah, you can find us on Twitter. You can also find us on our website, hive.xyz. And please follow my own personal Twitter as well, which is 0xDouwe. And it's a very Dutch name, so if it's hard to spell out, it's right here on the bottom left. So 0xDouwe. We also have a great documentation website, and we'll be making some updates to this documentation website pretty soon as well, as testnet is just around the corner. So yeah.
Well, Douwe, thanks again. And to the audience, I'll see you in the next episodes. Bye bye.